Hi there, welcome back. So today I'm gonna start lab 3. So we are done with lab 3, interpolation of point gauge precipitation or rainfall. In the last tutorial we have already interpolated the point gauge precipitation, right? The rainfall data we have created, and we created this map using creasing method, Thyssen polygon interpolation, and we also saw how to even interpolate the point gauge precipitation using a spline. So the image you can see right now, it is from the spline interpolation. So that is the most effective one for this type of study area, or the irregular shape of this study area. So now I'm gonna start a new tutorial called lab 3, where we'll delineate our watershed. We have our DEM data, right? Digital elevation data set. So from that one, we also have our flow line from NHD Plus. So we'll use these two data set to calculate or even to delineate our watershed. So that will be, I think, split it into two different tutorial series. So I'll start from now, and I think in the next segment of this tutorial I'll be able to finish that watershed delineation. So what will be the step, because it needs a lot of stuff, you have to follow this one. So I'll show you how to do that step by step. So I'm gonna share my screen at first. Today I'll also start with Arc catalog. You may have idea about that one, but for file copying and pasting and even creating geodatabase, I did everything in ArcMap, but it's pretty easy to do in Arc catalog. So I'm gonna open Arc catalog first today, and then from ArcGIS, if I open Arc catalog, I have to copy some files. If you want to copy some files, right, from one directory to another directory, so Arc catalog is the best way to do that. See, if you have any shapefile or any feature or any vector data, you will have different types of files in a single directory for one single file. But in ArcMap or in Arc catalog, you'll see we have only one file. Okay, so I already have this one there. So what I'm gonna do, I'm gonna delete that one from this. So okay, if I delete this one, I'm gonna select it from the very beginning. See, I'm gonna delete it. So if I create one file in another directory I have, see there. So I'll create lab 3 inside my, okay, there, lab 3, or here even I can create one. Okay, let me create one here inside that, not as a lab 3, a watershed delineation. So what do you have to do? I have to right click and then new, and if I click new folder by that name, this name will be watershed delineation. Okay, WS means watershed and underscore delineation. So that will be my name, and inside that one I have to copy the flow line, and I have to copy the DEM data. So where I have this from lab 1 and lab 2, so I also already have that thing inside my this folder as lab 3. So I'm gonna copy that flow line. If I select that, and if I want to copy my DEM feed, so these are the two files we need, this one, and if you want to select two files together, then you have to just okay, you can copy one by one. Okay, control is not working here, so just copy and then select that watershed delineation, and if you want to just paste it, you'll be able to paste it. That's pretty simple. Okay, you can copy and paste, but before copying and pasting, what we have to do, we have to create one geodatabase. Okay, we can create one geodatabase inside that folder. So when we created our folder, and then we have to create our geodatabase by the same name, or you can even rename that one. Okay, so that's the best way. It's time, because what we're gonna do, we're gonna even delineate watershed. So that will be a lab 3 as before, and then we have to paste everything there. Even I can copy everything from lab 2 and lab 1. That's what we need. If I go back, I have these files. I have to find this one. Probably I have these files inside that. Okay, so from lab 1 and lab 2, I can even copy these, or NHD Plus. I have all these things. It doesn't matter. So we also have lab 2 here, right? We also have, so we can even copy everything from lab 2 as well, it doesn't matter. So what we have to do, we have to copy our flow lines, and then we have to copy our DEM feed. First I'm going to copy this one, okay, just copying, and then just copy, and then expand this one, and then if you want to paste it here, it doesn't matter, we can paste it. You can even expand this one, and you can even paste it there as well. So that will be inside our geodatabase. See, it's just pasting. We have the DEM. Now what we have to do, we have to copy our flow line. Okay, so where is a flow line? We can copy it from this previous file we need. Here we can copy it, and then once we are there, we can expand it, and we can even paste it there. See, now we just pasted and we copied everything from another directory to this directory. So we don't need other directory. We can even, okay, we can collapse that one. So what we have to do, we have our geodatabase there, we have these two required files. So now I'm going to open ArcMap. See, it's pretty easy to open even ArcMap and ArcToolbox. Everything is easy to open. So I'm going to open it, and then I'll link the geodatabase with this ArcMap, and then I'll have access to these files, and then I'll do this processing we need to delineate Watershed. So let me show you how to do that once the ArcMap is done with opening. I'm going to create my template, and I have to even select this Watershed, right, that lab 3 that I already have created here inside lab 3. It is not that one. I have to go back, and then it is there in some other directories. Here it is. So where I have that, let me figure it out. It is inside that and ArcGIS, so it will be there. I have to go to there, and it's there, ArcGIS. Okay, and it's probably there. We have this lab 3, so we have to select lab 3, and then I'm adding that. So my home geodatabase or default one for this project is lab 3. So now if you click plus, then I'll have access to that two files we have. We can select it, drag and select, and if you want to add, it is going to add to our, I'm not going to show the pyramid, so that's okay. We have these two files. Okay, and let me check, because DEM feed is already in our state plane projection system, but I'm hoping that flow line is not that, right? It doesn't have that projection system. Maybe see, it has that state plane in feet, so we have to have the same coordinate system. So let me check that flow lines. If it doesn't have that one, yeah, it is in geographical coordinate system. So what I have to do, I have to project the flow line, right, to state plane. So we can do that using ArcToolbox. We have that toolbox, so we can click on ArcToolbox. When it will open, we can go to our data management tool, and from data management tool you can select on projection and then project. So I'm going to show you this one, that's why. So if I select that flow line is vector, so we don't need to select the projection system that we use for our raster. So what will be the name of this? So flow line raster. Okay, so okay, no, it's a state plane. That will be our coordinate system. So flow line state plane. Okay, and what will be the output coordinate system? So it will be the same coordinate system that we have for DEM. So how can you select that? Click on layer, and which one is for which one. So click on that one, you'll see, okay, expand it, you'll see it is for DEM feet. I'm going to select that one. So now if I click OK, so it will project right to state plane, and then we'll have the same coordinate system. So we don't need the flow line. I'm going to remove that. We have these two, and I'm going to save this project right now, and I'll continue with that one. So before saving the project, we have to select this one for future reference. Select this store relative path name and OK, and then I'm going to select the project as save as, and it is going to show you where to save. Okay, so I'm going to go back, and you can see we have that watershed delineation, and inside that watershed delineation we are going to select this WS and delineation. So that will be my project name, and I'll process everything. At first, what we have to do, I have to start with DEM reconditioning. So DEM reconditioning means we'll just make the DEM if it has any irregularities or any abnormalities. So in order to do that, I have to convert first the streams. These are the feature or vector, so this feature to raster. So how can I do that, right? In order to do that, we have to do some spatial analysis tool. If you are not familiar with that one, so click on customize and extension. If your extension is okay, spatial analysis tool, if it's checked in, then you can get access from here. So click on arc toolbox and go to at the very bottom, and you can see you can find the spatial analysis tool. Expand it and you will find different options, and out of these options, what you have to do, you have to select that, right? We're not going to do that. Before going to do that, we have to convert it from conversion to, right? We have to convert it from feature to raster. So we are gonna convert it from conversion tool to raster. Since it is feature, from feature to raster. Okay, I'm gonna convert that. Which one? Because we have to convert the flow line based on com ID, and the cell size for DEM, we know the cell size is what? Cell size is 97.44 feet, right? So we have to make the same flow line. So I'm going to select the flow line state plane, and field will be that com ID. It is the common ID. We already have idea about that one. It is the ID of a segment. So we have the flow line, okay, flow. So these are flow line raster. This will be flow line raster. So here, what do we have to do? We have to even set the same cell size. How can you do that? We even provide the cell size manually, or we can change our environment, right? How can I do that? Click on environment and then processing extent. Here we can select that same as DEM feet, and here snap raster, it will be also DEM feet. If everything is okay, then it will automatically select the cell size right here. And if you know the cell size, you can provide the cell size as it is, not a problem. If I click OK, hopefully it is gonna convert that feature or flow line to raster. You can see that if I turn this off, you can see we have this raster right now. And if I just zoom in, you can see the same cell size. If I turn this off and on, you can see it's messing with the cell size. Okay, so that is called raster, flow line raster. We have, if I just right click and zoom to layer, it will be this way. Now if I even want to change the symbology, if you want to see that, we can even do that for each of the cell ID. Go to symbology, and for each of this com ID, if you want to see the unique values, so it will show you how many values we have, and it will give you different number, different color. So that's that, we have different color for each of the cell ID. So the same color means we have one com ID, and that is the one segment of the stream. We can even identify that way. So now what you have to do before creating that reconditioning, we have to create the binary raster. Means these are the flow line we have where we have a value, and where we don't have the flow line raster, so it is no data, right? So we have to even create that one. So how can I do that? We have to use a logical operation. So these are the raster. Now we have the raster. So if you want to do some processing on raster, so we have to go to a spatial analysis tool, and from spatial analysis tool we have to find the math, because we are going to do some mathematics here, and then we are going to do some logical operations, logical, and we are going to do some this type of logical operation, either it is greater than or less than. So we are going to use a greater than operation here. So if I select that flow line raster, now I'm going to select everything. Okay, I'm going to describe that, and here it will be 1. Okay, so what I'm going to do, basically you can see that I'm going to select everything that is greater than the flow line raster. The value will be 1, otherwise it will be 0, right? So that is the thing. So the input against which the first input is tested to be greater than. So we have the flow line raster. If the value is greater than this value 1, then it will give 1, otherwise it will put 0. That means it will find where we have the flow line. That means we have the value greater than 1, because the ID, you can see these ID all are greater than 1, so it will give you the 1 value. Otherwise, where we don't have any flow line, it is empty, or other than 1, that will be no data basically, so it will give you no data or yeah 0. So that's the thing we are gonna do right now. If I click OK, and if I have to change the name, it will be binary, okay, binary raster. So it is binary raster. I'm gonna save that way, and everything is okay. We don't need to do even processing environment, or we don't need anything. Okay, so I'm gonna just click OK. It will give us that binary. Let's see, it will give us no data for the place where we don't have. See, we already have that. And let me check that. If I turn it off, you can see that we have only one value, right? We have only one value where we have the flow line. Otherwise we don't have anything because it is no data value. Now what we have to do, we have to reclassify, right? In order to do some operation, we have to reclassify this thing. How can I do that? Because we have to provide one where we have the value of streamflow raster, and we have to provide 0 value where we don't have anything. So I have to go back to that. We don't need math operation anymore. We have to go to reclass. You can see that we have the reclass, and from reclass we have to select reclassify. What I'm gonna do, I'm gonna select that binary raster here, right? That binary raster, and from that binary raster we are just gonna calculate the condition. We are going to change the notation based on the value, not the count, okay, based on the value, keeping that in mind. So the old value we have in the binary raster, we have 1, and the new value should be also 1. The old value is no data, but the new value should be 0. Then we can even calculate later on. We can use this data as operation or different types of calculation. Okay, so when we're done with that one, we have to change the environment variable here, environment condition, same as before, right? Processing extent should be same as DEM feed, and then that snapping should be DEM feed, because we are gonna select the same cell size as the DEM has, right? And then if everything looks okay, then we can click OK, and then it will convert. Okay, it will convert if I click OK here, and if it is okay, no data will be 0 and 1 will be 1, then that will be reclass. Okay, what will be the name of the raster? We can give the name as either reclass or whatever you want for this case. Okay, and even we can change the raster as, we have to do one more thing, I forgot that here, raster analysis and mask. That will even cover the entire mask, because we have some raster, right, that is just going off or going outside of this DEM. So that's what we have to see, mask. Yeah, the raster analysis tool, it will be mask, and mask will be DEM feed. And if I click OK, then it will process and it will reclassify everything. I'm gonna hit OK, and let's see what it is gonna do. I'm hoping that okay, it's gonna reclassify everything based on that information we have provided. See, we already have that, and you can see we have changed color. If I turn this off, you can see we have only zeros and ones. Okay, you can see the value we have, this color, this is 0, and where we have the stream network, it is 1, the purple color. Okay, so that is pretty nice, right? So I'm gonna zoom to layer. So that's it. Now what you have to do in order to calculate the DEM reconditioning, we'll just card the DEM based on a certain condition. I'll show you that. Before doing that, we have to calculate the Euclidean distance, right? So in order to do that, because the Euclidean distance is nothing but a distance from one stream to another one, so it will calculate that. And in order to do that, we have to do same thing, go to spatial analyst tool, and then from here find the distance here, and then find the Euclidean distance, not the direction. Okay, if you click on Euclidean distance, then what we need, you need to select the main flow line we have, flow line straight, right, straight plane, that one. And then what will be your, that just click that distance. Okay, distance raster, this will be a distance. And then what we have to do, you have to select the environment again, and before that here, what will be your input barrier or raster? So that will be the binary, okay, or reclass, whatever you select, it's okay. I'm gonna select that reclassify the raster we selected, and then you can get the cell size from here. And as processing unit, I'm gonna select that extent as DEM feet as before. Snap mask, it is DEM feet, everything is same. And then we have to select the raster analysis as before and select that mask as DEM feet, then click OK. If everything is okay, then we'll get this distance, okay, this distance. Then I'm gonna hit OK, and let's see if we are lucky, then it will calculate everything pretty accurately, and we'll see pretty nice look of the distance. And then we'll calculate something using map algebra, and then we'll have pretty good idea. So it didn't work this time, that's why I'm gonna save it. Okay, I'm gonna save it and I'm gonna open it again, or I can try. So these are the things, sometimes this Euclidean distance, it doesn't work. Okay, this time I'm gonna even select the same way as before. Okay, I'm gonna keep it that Euclidean distance, and then input raster barrier. I'm gonna provide binary raster this time if it is okay, and we don't need to provide the okay, the distance it can take from this one, and processing extent. That's why for calculating Euclidean distance I feel worried about it always, so it depends on the processing. So what will be the raster analysis? It will be the same as DEM feet. If it won't work, then you have to restart your ArcMap software, then it will definitely work. So these are the rule. If you face some problem, you can solve it. So I'm gonna give you these tips. Okay, then if I hit enter or click OK, then it's gonna, hopefully it's gonna calculate that value. We have this value, but these are not correct. These values are really big value. We don't want to do that. Maybe this time it's working because it's taking time. Otherwise, yeah, maybe let's see if it really working. Yeah, it worked. You can see pretty nice color of Euclidean distance. I'm gonna delete this one. Okay, so we have this Euclidean distance, and from that one, what I'm gonna do, I'm gonna create that DEM reconditioning. So I'm considering I'm gonna dig right this type of canal or this type of funnel shape channel from the stream. So that's why we need the distance here. I'm gonna use this equation, and we'll use our DEM feet here. Then we'll calculate that equation, right? Flow line reclass, we have that. We'll use this because we're assuming that this funnel, right, the bottom of this funnel, it will be 30 feet and then top will be 30. That's why we have this 30, and basically we are going to calculate the area, right, of this cross section, nothing else. And we have 3000, and from this one it is triangular 1500 feet. So that's that. So we'll use this formula to calculate the area of this funnel shape cross section. Okay, so that's why we are deducing, because we have the DEM right like this way, right, the rectangular thing. So we are deducing the 30, we are calculating this one, right, multiplied by our flow line reclass. If we have raster, right, the reclassify with 0 and 1, then it will calculate, and then if it is 0, then it won't, and then we are reducing that one other part. So these are the 30 into flow line, and this is the other part, 1500 minus 0, and we are giving the condition as distance less than 1500. So that's the condition. If the distance is 0, it will calculate, and if it is up to 1500, then it will calculate this cross section. Otherwise, if it is more than 1500, it won't calculate anything. This is the condition we provided the thing. If you increase this number, you can change these numbers. How can we implement this equation in the raster calculation? So we can do that. We have this technique there, map algebra, and raster calculator will provide you that one. Okay, so what I'm gonna do, DEM feet, we have everything there, DEM feet, and from DEM feet all deduce. Okay, we have negative sign and 30 multiplied by flow line reclass. We have that flow line reclass, right, this one, and then we have to even deduce this one as before, as the equation is 0.02, and then we have to provide this. Okay, let me quickly remove that one, delete. Okay, star multiplied by that way, because this is very sensitive, and 1500 minus that flow line distance. Flow line distance means the Euclidean distance, so that minus Euclidean distance, and then we have to close the parenthesis, and then we have to provide the condition as this way. It will be flow line distance means that Euclidean distance, okay, and this should be a condition if it is less than 1500, or it will go up to 1500, and then I'm closing the bracket, okay, and I can give this name as DEM reconditioning, okay, DEM reconditioning, DEM reconditioning. Then it will save this. Let me check the equation. This is DEM feet minus, I'm checking the equation, 30 multiplied by that reclassification of the raster minus 0.02, and then it will be multiplied by 1500 minus Euclidean distance. It will check the distance. It will go up to 1500, right? That's the condition we are giving. Euclidean distance, if it is less than 1500 feet, then if I'm gonna click OK, then it will calculate the DEM reconditioning, and then we'll check, okay, we'll check if we can do that. And how can we make sure that, okay, we have this thing? We can take the difference, okay, because we have the DEM reconditioning. It's, if I zoom in, we don't need the reclass. See, if we zoom in, we can see the changes here, right? But we can't even differentiate the changes. How can I do that? If we take the difference between the previous DEM and this DEM, then we can even identify, okay, this is the change we have. Again, I'm gonna select that raster calculator, and then main DEM we have, and minus the DEM reconditioning we have created, and here I'm gonna select, this is the DEM difference, okay. Then we'll see the difference between these two DEM, and you'll see where we have the calculation and where we didn't have that calculation, okay. So I'm gonna save it. It's not gonna take that much time. I hope that, yeah, and you'll see it is pretty nice, clear picture. See, you can see that this is the location where we have that formula, and we have this funnel shape cross section of the stream, right? We can see that it's pretty clear. And from this one, what we can do, we can even see, okay, I'm turning this off, turning this on. If you want to see the cross section after reconditioning the DEM, what will be the cross section? What do you have to do? You have to right click and then select that 3D analyst tool, okay, 3D analyst tool. If you can't find that, go to customize extension, and here you can see 3D analyst tool. If it is turned check in, then you will find that, right click and then 3D analyst, and you will have this menu. Put it there, drag it down and put it there, okay. It is pretty convenient to put anywhere within this tunnel, okay. And then I'm gonna select which one we need. We need DEM reconditioning, okay. I'm gonna select that one, and then it is activated. So if you select there, if you check everyone, so it is interpolate point, it is interpolate line, okay. So I'm gonna select that, and if you wanna see, click there and double click there, it will, and then this is activated. If you wanna see the profile, click there, it will show you the profile of this river. See, now it is really pretty nice plot of this DEM, right? So see, the highest is 35, lowest is 0 elevation, and it is the river section, pretty nice section, right? So these are the modification we have done here. And if you want to even delete that, just press delete. If you want to select any other location here, you can see, even we can select both, and you can see two river cross section. After that, you have to select there. You can see it is the big one. And if you want to export that, you can do that. Just right click, and if you go to properties, even you can change the name and appearance, right? If you want to change the title, you can do that. Even you can change the title of the graph, okay. Here profile means of cross section, okay, cross section of the river, okay. We can do that. And at the footer you can do this, and there are different, if you want to see 3D view, we can do that. Apply, you can see 3D view, you can even turn this legend, you can do that. and even you can give the title as well, left position, right position. You can do that, the left position, and you can give the title as elevation, and it will give you everything. Okay, elevation in meter or elevation in feet, so it's gonna give you everything. Okay, and you can give that it is in feet, right? So these are the option, and you can change it to logarithm. See on the left side you can see the elevation, and what you can do, you can even use your Windows screen, or you can even, okay, I'm just gonna delete that. It's creating another plot. Okay, we don't need that. Okay, so if you wanna crop that, we can do that. Okay, you can crop it using any screen cropping tool. Okay, so this is called DEM reconditioning, and after that what we'll do, we'll go for watershed delineation. So that is another segment of this tutorial, and we'll finish that, because if I start that one right now it will take a lot of time. We'll use hydrology tool right now. We have done this thing, we are done with that one. If I just collapse this, see, we can see the hydrology tool. Next thing we'll do, like this fill, we'll fill this DEM. See, we have some irregularities there, right? We can select this DEM fill, we can then calculate that flow accumulation, and then we'll calculate flow direction, right? And even at the beginning we'll sync the DEM. These are the processing I'll describe, and finally we'll calculate everything, right? And then we'll have our watershed delineation. So we have to do all this processing, and it will take a while. That's why I'm going to finish up here, and you can even try by yourself up to this point, and then let me know if you have any problem, or I think definitely you'll be able to do that. Okay, you can do anything. Anything is possible here in GIS if you know the actual processing. So that's that. Thank you very much for watching, and stay safe. See you in the next tutorial. Bye.